Hello, and welcome to a little video about the test review. Let's get started. On number 1, we're going to calculate the average rate of change. So that's our rise over run. I'm going to pick 2 perfect points, right there and right there. And I'm going to go left to right. To go from my left point to my right point, I have to go up 1. That's my rise. It's positive 1 because I'm going up. And then I'm going to go to the right 2. That's my run. Success! Onwards we go. Number 2, let's calculate the average rate of change. Now the way we calculate our average rate of change is by using this formula right here. So I'm going to label things y2, y1, x2, x1. All right, let's plug things in. We have negative 4 minus negative 10 over negative 3 minus negative 6. Now when I plug this into my calculator, negative 4 minus negative 10 gives me positive 6, and negative 3 minus negative 6 gives me a positive 3. Now unfortunately, I don't see any answer that looks like 6 over 3, so I'm going to simplify it. 6 divided by 3 is 2, so C is our answer. Number 3, a tree is currently 12 feet tall and grows 5 feet per year. Let's model this scenario with an arithmetic sequence. Now the way we do this is by plugging it into this formula right here. The first thing that we write down is our initial height, so that's 12, and then we write down our pattern. For letter B, what we're going to do is rewrite this in simplified form. What that means is I'm going to actually distribute and combine like terms from the formula above. So first I'm going to multiply 5 times n, which is 5n. Then 5 times minus 1, which is minus 5. I've got one more thing to do, and that's combine some like terms. The only like terms I see are the regular numbers. 5n stays 5n, but 12 minus 5 gives us 7. So that is our answer. Letter C asks us to calculate the height of the tree in 16 years. We do that by plugging 16 into the formula we have above. 5 times 16 is 80, plus 7 is 87 feet. That's a big tree. For number 4 and 5, what we're going to do is we're going to transform the graphs that we're given. Now, number 4, we're given the graph 2x plus 5. We want a graph f of x, which is 2x plus 5, minus 7. Now, I've got to combine a couple of like terms here, and that's that 5 minus 7, and I get 2x minus 2. So, the negative 2 is where we're going to be starting, the minus 2. So I'm going to draw a dot on minus 2 on the y-axis. The 2 next to the x is our average rate of change. Now it's just a whole number, so I'm going to rewrite it as 2 over 1 so that I could see the rise over run. Any whole number can always be rewritten as over 1. Let's do this. Up 2 to the right 1. There's our graph. For number 5, we're transforming, but by multiplying. So we have the graph 2x minus 3, and we want to multiply it by negative 2. So I'm going to write negative 2, and then in parentheses, 2x minus 3 right next to it. Let's distribute. Ba-boom, ba-boom. Negative 2 times 2 is negative 4, and negative 2 times negative 3 is positive 6. Sorry? Thursday, Friday. Next week. I'm not going to start this over. We're on number 5. I was just answering a student about when this test is, which is going to be next week from the day that I posted this. Anyways, I'm just too far in. I don't want to start over. Okay, so I'm going to start plotting on positive 6, which is right here. It's kind of out of the way, but that's fine. My rise over run is negative 4, so it's actually negative 4 over 1. Every whole number can be written as over 1. So I'm going to go down 4, that's what the negative means, and over 1. We're done. Let's continue. Okay. Let's solve each equation. Let's start at number 6. The first thing that I see that needs to happen in number 6 is on the right side, I need to distribute. So my left side stays exactly the same, but let's see what happens on the right. 7 times x is 7x. 7 times minus 4 is minus 28. Beautiful. Let's begin moving things around. I want my x's on the same side and my regular numbers on the same side. I'm going to begin by moving my 5x over to the other side. And what I mean by other side is other side of the equal sign. Okay. They cancel here, and we have 12 left over equals 7x's minus 5x's gives us 2x's, and the minus 28 is left over. Next, I'm going to move the 28 by adding 28 to both sides of the equal sign. We add because I had a minus 28, and I have to do the opposite operation. And I did not give myself enough room, so I am attempting to make, to make this smaller. Success. Okay. 12 plus 28 is 40, equals 2x. And my last step is to divide both sides by 2. X equals 20. Number 7. Oh, beautiful. We don't need to distribute at all. So I'm going to begin by moving my x's over. Now, I want to remind you that an x by itself is really one x. So I'm going to subtract a single x from both sides. Here they cancel, and I have 6x minus 20 equals, this is the easy part to leave out, a negative 2. The minus goes with the 2. Okay? Next, I'm going to move the 20 over by adding it because that's the opposite of being subtracted. We're left with 6x equals negative 2 plus 20 is 18. And we get to finish this up by dividing both sides by 6. X equals 3. Oh, whoops. Here it is. X equals 3. Okay. Onwards to number 8. Determine whether the equation has one solution, no solution, or infinite solutions. The way we do this is by looking at the x's. But before we can even look at them, we've got to do some distributing on both sides. Okay, so that's 20x minus 28 equals 20x minus 10 minus 18. I'm going to combine a few more things before we look at it, and that's this minus 10 minus 18. So on the right side, I still have 20x minus 28. On the right, I have 20x. Negative 10 minus 18 is negative 28. Okay. Now, what do we notice about the x's on both sides? We have a 20x and a 20x. They're exactly the same, so I can just cross them off. I'm left over with negative 28 equals negative 28. Is that true? Yes. That means we have infinite solutions. Number 9. Mr. Miller saved $162. He has already spent $40. He plans to spend $12 on Netflix subscription each month. Let's find the inequality that represents what he can afford. What I like to do is just write the inequality myself first and see how that goes. Okay, so Mr. Miller had $162. Can he spend more than $162? No, so $162 has to be on the open end. He can spend exactly $162, so he has to have an equal sign, so it's less than or equal to. Unfortunately for us, all the letters have that, 162 on the open side. Okay, fine. Next, he's already spent $40, so I'm going to write down 40 because that can't change. Now this 40 is positive, so that allows me to cross off letters C and D. And Mr. Miller plans to spend $12 on Netflix each month. So and is addition. So A and B both have, oh, actually just B has a positive 12. There we go. Modeling linear inequalities. All right, we're going to solve and graph. Let's do it. For number 10, this is a little one-step inequality. We're going to divide both sides by -6. On the left, we're left with x. On the right, -5. And because we divided by a negative number, my symbol flips. Now this is a greater than or equal to. So when we have a symbol like this or like this, we draw a closed circle. Filled in circle, there we go. X is on the open end of the symbol. It's the greater than. So I'm going to point an arrow to the right because the numbers that are greater than -5 are on the right. Number 11, okay. So I need to get x by itself. And the first thing I'm going to do is subtract 39 from both sides. We're left with -x. I'm just subtracting, so my symbol doesn't change. 42 minus 39 is 3. Now, -x is actually -1x. So I'm going to divide both sides by -1 because I'd like x to be by itself. We're left with x on the left, -3 on the right. And because we divided by a negative, our symbol flips. Let's graph it. When we have an inequality symbol like this or like this, we draw an open circle that looks like a little face. It's funny. An open circle, -3. Because x is on the open side of the inequality symbol, it's greater than, we draw an arrow going to the right. Okay, last question, number 12. The junior club is selling boxes of popcorn in order to raise money to go on a field trip. The function represents the total sales for 600 boxes being sold. The club will only have enough money if it reaches 800 or more. Let's graph it. So here is the graph that represents how much money that the junior class will make as it sells boxes of popcorn. The goal is $800. So let's find 800. Whoops, I colored 1,000 in as well. That's fine. I want to see, where does 800 intersect our graph? Right here. This point right here, that would be our exact goal. That's 800 on the dot. But why stop at 800? Let's make more money. So we're shading this part of the graph. Anything over here would be us reaching our goal or even making more money. And that's really it. Okay. If you have any questions for me or for your teachers, please let us know. Otherwise, have a wonderful rest of your day. Happy studying. Bye.